Let's take a look at some important Unix commands that can be quite helpful regardless of the distribution that you find yourself on. We'll get an instance of the shell going. This brings up our gedit session. And we'll label this section Basic Unix Skills. We'll present a number of commands in no particular order that you should be familiar with. So the features include myriad, navigational, and data processing commands that are consistent across Nix-based implementations. So, for example, in no particular order, when you open a shell, regardless of where the shell is located, so it could be a pseudo terminal such as one we find ourselves in with this particular window, or perhaps even a terminal that's actually connected to the console. You log in, and the first thing you do is you see a prompt and you are wondering where you are in the system and what you can do or cannot do. So here's our prompt. Unix CBT at Unix CBT 1. Unix CBT 1 happens to be the short name of the FQDN, and of course Unix CBT happens to be the currently logged in user. So who are you on the system? The prompt tells us, because we're running bash, that we're logged in as user Unix CBT. But who am I will always concretely return to you, regardless of Nix-based system, the currently logged in user, even if you've SU'd in or switched user contexts into the system. So who am I is one of those important commands. Let's just go back to our gedit. And commands will be placed between single quotes whenever we document them. So who am I enumerates currently logged in user to a given shell. TTY, as we've already mentioned, tells you the pseudo terminal that you're currently connected to in this particular case, because we're within the GNOME environment. If you're connected to a normal console, then it simply returns one of the items from etc TTYs that's configured. So TTY dumps current TTY, pseudo terminal or otherwise. So we are in this window on pseudo terminal number 1. And since pseudo terminals as well as normal terminals are indexed at 0, it immediately tells us that there is a connection open somewhere to another terminal, indexed at 0, of course. That leads us to a series of W commands. W by itself will tell you the currently connected consoles, whether pseudo terminal or actual consoles. So this tells us, for example, that the user Unix CBT is connected to pseudo terminal 0, and has most recently executed gedit followed by the name of the file that we have open to the left. So this gedit window was invoked via pseudo terminal 0. And W gives us that insight. So it returns current TTYs and attached programs or processes. And there are a number of them, including who, for example, which displays the information in a slightly different form. Some others include pwd. So for example, when you're in a directory, it's nice to know where you are. If you're using the bash shell, it tells you where you are. However, pwd will print absolutely from the top of the directory hierarchy, which is root within Unix-based systems. So this tells us that our current directory relative to the root is home Unix CBT. It's reflected by the tilde variable, which is maintained by the bash shell. So pwd is another one. And this prints the working directory. Another command that's of importance is cd. This is a navigational command. So changes/navigates directories. With no options, cd changes you to your home directory by default. with options such as a particular directory to navigate to, CD will take you there in the event that you have permissions to view or interact with the directory. So for example, we're currently in home Unix CBT, so CD / navigates us to the root, the absolute root of the Unix file system. CD with no options returns us to our home directory. CD with a relative path such as CD ... takes us one level up, which is simply home. No options back to our home directory. CD ... changes us to the current directory. That leads us to another command, ls, which lists directories. So in addition to navigation, you also need to know how to enumerate the contents of directories. Directories themselves are also enumerated when using ls. So enumerates directories / files. ls with no options shows a wide display with no metadata about the entries that are within the given directory. So there's no easy way to determine, unless you have colorization enabled, whether or not an entry is a directory or a file. However, with the long option, we can then make the determination. This tells us, the leading bit here, D, that desktop is a directory as opposed to a file. The leading bit being a hyphen tells us that the item is a file and not a directory. So LSL. And leading D indicates directory, whereas a leading hyphen indicates a file. There are other types such as character, binary, etc., character device, etc., name pipe, etc. File types may be binary, text, etc. So there are a number of types that are available, but the common ones that you'll see are directory and hyphen or absence of D, which indicates that the item is just a standard file. LSL not only shows the types of files insofar as directory or file is concerned, but also the ownership information. So this shows that the file is owned by the Unix CBT user and by the group Unix CBT to which the user belongs to. It also reveals the size of the entry. So as we can see, the desktop directory reflects 512 bytes, whereas the file Unix CBT BSD8x notes represents 2605 bytes, and this core file represents 5410 and just about 5.4 megs approximately. So ls with the long option returns more useful information. There are a number of other key options. For example, to expose hidden files as well as directories. Directories are simply special types of files. We use the A option. So LSLA, for example, long format with the A option will also return items that are hidden. In Unix, as is the case with Linux, hidden items are prefixed with a dot. So LSLA, and let's just include the A option, returns hidden items. And those items may be files as well as directories. And as a quick note, in Unix, a prefix of simply dot means the item is hidden. But of course, if you know the A option to ls, you can expose the item. And of course, permissions still govern whether or not the user is able to interact with the item. ls supports a number of other options, such as the ability to sort content using, let's say, lsltr, which sorts the most recently created item towards the bottom of a list. So if you look at the chronology, 14 followed by early 15 followed by later 15. So lsltr is a way to sort content in a useful fashion. Yeah, it's quite useful. So long as you're using bash, it's consistent across distributions. So sorts most recently updated item at the bottom of the list. And this can be reverse sorted as well. And you can sort on other metadata, for example. So ls with the long option, the key is that it returns metadata. So note, L option returns useful metadata. This leads us to another useful command, and that's stat. So sometimes you'd like to learn more information about an object. So here is a file, UCBT BSD8x notes UCBT1.txt. What other information can we learn about the file, such as its permissions, its size, when it was updated, created, modified, which is updated, etc. Stat against the file name returns that information. So notice when we execute stat, it shows us that information. It shows us the byte size as well as the location in the tree and other useful information, who owns it, user ID that's tied to it, etc. So stat returns that. Another command that's of interest, let's just note, returns useful metadata. And the metadata, by the way, that's returned is file system dependent. Each file system maintains its own batch of metadata. So if you're accustomed, let's say, to Linux with ext3 or 4, or RiserFS, for example, you may see different metadata than displayed by UFS v2, for example. So supposing you need to create a file or update the timestamp on a file, there's a command touch that you'll see referenced a lot in shell scripts. So touch creates an empty file or updates modification timestamp on the item. So let's look at our directory LSL. These are all items that are visible. Supposing we'd like to create test.txt, an empty file. Touch test.txt. Echo the exit status. It's clean. That now means we have a file named test.txt. And note that it was last updated relative to the current date within the same minute. So touch will return that item for us, an empty item. It also will update an existing file. So as the time elapses, you can update other items. For example, the notes file was last updated at 12:59. Let's touch it. And let's LSL it again. And now notice that the notes file was last updated at 13:02, which is still the current minute for another few seconds or so. So touch will update that timestamp information for you accordingly, and it's often referenced. Now notice gedit has picked up on the change. So we'll reload, and this will reflect the change. So let's just go back in here, and it sees that the file has changed, so we've lost those settings. So that includes, for example, touch. We could have ignored it, which would have preserved the settings there. So touch updates timestamp or creates empty file. Another useful command is echo. Let's save it here at this time. Echo dumps whatever you tell it to dump. So echo dumps to standard out, which is the screen, whatever you instruct it to. This can be quite useful when you string it together in a series of, let's say, redirections. So for example, we have this empty file test.txt. Let's populate it with a line that reads, "This is a test." So echo, and we'll place what we want to echo between quotes. This is a test. This will be dumped using standard redirection to the screen by default, but to dump it to a file, we use append redirection to send it to test.txt. We'll talk a little bit about redirection in the next section, but for now, let's just take this item, copy and paste it, Control-Shift-V. And now, after we echo the exit status, which is 0, which means it's clean, we'll again LSL test.txt, which is now 16 bytes. Another command that's useful is cat. So we've just populated "this is a text" followed by a dot or a period or a full stop into test.txt. However, how can we enumerate the contents of the recently populated or updated file? One way is to use cat, which catenates or concatenates. Its basic purpose is to merge together content from disparate sources, but it also has a simple purpose of being able to just enumerate for us to standard out the contents of one or more files. So enumerates file content to standard out, which is the screen, the current terminal that you're on. And when used in conjunction with redirection, can send that output to a file if you'd like. So a cat of test.txt dumps the characters that we've recently populated. So that proves that what we've echoed to the file has been placed in the file. Let's echo again. This time we will reference that this is a second test. And now the file should be double its size. It's actually a little bit more, 39 bytes. Now let's cat the contents of test.txt. We should see the two lines, the first test and the second test. And it's a little bit larger because of the word second. And that's what cat allows us to do in its basic incarnation. But for a little bit more sophisticated use, you can bring together content from multiple sources. So for example, if you'd like to merge the contents of, let's say, test1.txt and test2.txt into test3.txt, you would do something as follows. Cat test1.txt, test2.txt into test3.txt. So this causes cat to enumerate the contents of test1 and test2 in the order in which it's presented, sending it using redirection into this file named test3.txt. Now, if the file doesn't exist, it'll automatically create it. But we currently don't have test1 and test2, so let's echo 1 into test1.txt, and then we'll echo 2 into test2.txt. And now let's cat both test1.txt and test2.txt to see what will be dumped to standard out. Content from the first file, content from the second file. To create that third file, which currently doesn't exist, simply cat the contents and send the output as we have in our command to a file named test3.txt. This is called clobber redirection, and when a file doesn't exist, it creates it, and if it does, it simply truncates it and populates it with fresh content. So now, let's echo the exit status. It's clean, and if we LSL test star, we should see that test3.txt represents the aggregate of test1 and test2. Both test1 and test2 are 2 bytes each, which means test3.txt should be 4 bytes, unless there's superfluous data such as tabs or lines or other things that we don't see, non-printing characters, for example. So in its simple incarnation, this is how cat works. Now, of course, this can be stretched to more complex examples, such as concatenating the contents of one or more log files, which may be more useful. Simply reference your log files and aggregate them into a target log file. When used in conjunction with pipes and other programs, such as grep and so on, then things become much more powerful very quickly, and as a consequence, highlights the power of Unix. Now, since we're still within the basic command set, let's show you some more basic commands. To make a directory, since you now know how to make a file, which is by using touch or by simply using append or output redirection, to make a directory, we use the make dir command. This creates a directory. Now, make directory with no options does nothing. It prompts us to specify a directory to create. The directory can be prefixed with a path that's relative to the current directory, relative to the root, which is an absolute path, or simply, if omitted, meant or interpreted as relative to the current directory, which is a single dot. So let's make a directory, temp, and now we have a directory called temp. To confirm it, we'll LSL. So there's our directory temp, which is 512 bytes, and that means it uses a single sector insofar as our UFS file system is concerned. So there's the directory. Its timestamp represents the current timestamp, 1309. Now we're into 1310. And it exists. It currently has no files, but it exists. Now again, the default is to create directories relative to the current directory. So defaults to current directory, which is simply referenced as a single dot. And in each directory, there is an implied dot and dot dot. And this goes across operating systems. Notice the dot and the dot dot let's just copy and paste these two entries. We use the A option to reveal it since a leading dot means that the item is hidden. So let's just paste this in. So let's just note dot means current directory. Whenever used in any of your tools that reference paths, which is basically most tools. And dot dot means one directory up in the tree, in the directory tree. So those are the references. So whenever you reference dot, for example, you mean the current directory. Now to prove it, we have a few test files here. Let's cat ./test3.txt. That is the same as simply catting test3.txt. The dot simply means the current directory. The / is just the Unix way of saying the directory. So that's how you make a directory. How about removing a directory, which is also equally as important as you navigate and maintain objects throughout the file system. So remove dir will remove your directory. So let's get rid of temp. And then echo the exit status and then LSL, and you should see that temp has disappeared. So dir temp removes directory. However, there are times when you need to remove directories recursively. So you use rmrf, the remove command. Removes directory recursively. Recursively simply means to include also sublevels. So for example, let's remake temp. Make directory temp. Then beneath temp, let's create another directory, temp2. So now our temp directory contains one object named temp2. Let's try to remove directory temp, which we just recently did. And because the directory is not empty, it contains one entry, remove directory doesn't work. Now let's remove rf temp, and you see that it removes the item. So that's why we use the rmrf option. So removes directory if not, or if is empty. If it's not empty, it will not remove the directory. You should then use rm with the rf option to remove that recursive entry. And that includes any number of recursive items, such as files that exist beneath the directory. Now let's just look at a few more before we go on to another batch of commands. So the bash shell maintains a history. And to echo the history, you don't simply type history as we've done, you simply type history. So in other words, it's a built-in. If you do a which history, for example, notice it's not a command. You don't find the file. It is a command, but it's not a file. It's not a binary. It's a built-in. History enumerates the history of commands that you have typed. So enumerates history of commands executed. And where does this lead to? Well, oftentimes we reuse the same commands. So rather than retyping the commands, you can reference specific commands from the list, from your history. So supposing we'd like to execute command number 61, we simply reference with an exclamation mark in bash 61, and that performs command 61. So the importance of a history is that we can quickly refer to commands that we have recently used. And oftentimes commands can be quite complex. Think of a Java process, for example, with a long command line that includes a long class path, etc. Rather than retyping it in or copying and pasting and running the risk of losing a few bits, you simply consult your history, especially if you're executing or looping through the same command time and time again. So that leads us to the other built-in, which is the history num. So i.e. exclamation 61 executes the 61st command on the history list. And each user maintains a separate history file, a bash history file, in the user's home directory. So it isn't in memory, it's in a file. And if you look at the various hidden files, you'll see that there's a bash history file This file contains the history. So you reference the items as you see fit. Now, Bash shell also supports the ability to execute commands using exclamation sans a history number. So if you'd like to execute the most recent invocation of ls, just execute exclamation ls, and that executes the most recent item on the list. So exclamation command executes the most recent invocation of that command. So for example, exclamation ls invoked ls-l. And again, as your commands become more sophisticated, this becomes much more of a concern. Some pagers that may be of interest. What's a pager? A pager is simply a command or a program that displays textual information one page full at a time and is customized to the dimensions of your terminal. So we've constrained our terminal. We have more real estate that we can use, but this was done so that we could purposely use our pager. Two common pagers are less and more. I prefer to use less for historical purposes. So you've got more and less. Both are pagers, and they display textual data one page at a time. So if you have a file that contains a number of items that'll overrun your screen, for example, that's where the pager comes in. Or in the case of dmessage, which certainly overruns the screen regardless of how big it is, you can pipe the output into your pager such as less to take a look at it. Now our files here, let's see if there's anything that's of interest that exceeds our screen. Nothing does currently. Let's cat test.txt. And it doesn't contain much. However, if we less the contents of test.txt, you'll get the picture. And that is, it displays one page full at a time. In this case, the document happens to fit within a page without us having to use the features of the pager. Varlog tends to have items that will overrun the screen, but most of the items are not accessible to a non-privileged user. One that may be of interest is the messages file, but it's only 79 bytes currently, so it's not good enough. Mail log would work, but it's not big enough. Xorg log might be of interest. Let's try to take a look at this file. Well, less varlog, Control-Shift-V to paste, and this is a good example. So here's one page full of information. Spacebar advances you another page full of information. B takes you back or retreats or regresses one page full of information. So B and F, you can alternate between B and F or spacebar and back to navigate a full page. So use B to go back a page and use spacebar or F to advance a page using more or less. So those are two pagers that are of interest. Now there are a number of other commands that are important and features of the Bash shell that we'll be looking at in the subsequent section.